Bresenham's algorithm. Here, suppose say that our initial point was SKYK, and let this be the original line. So this dotted line represents the original line, and here SKYK, our line passes through SKYK, and SKYK, suppose say that these three are three LEDs in the screen. So in order to represent SKYK, we can make this LED bright. But when we are going to the next point, there the original line is passing like this. There we do not have any LED, but we have the one at the top and one at bottom. So the top one can be, top coordinate nearest to it can be called as SK plus 1 YK plus 1, and the lower one is SK plus 1 YK. So we are in a confusion to switch on which of these two LEDs to represent the given line. And for that, what we do is we will take the distance of our line from the top LED and the bottom LED. Suppose say that from the top LED the distance is D upper, and from lower LED the distance is D lower. So now we will find D lower minus D upper into dx. This is actually to make the mathematical formulation simple. Just to explain it, this is sufficient. D lower minus D upper. So now, if D lower, and we are denoting that D lower, dx into D lower minus D upper as pk. If this pk is negative, that means D lower minus D upper is negative. So for that to be negative, D upper should be maximum. D upper maximum means the distance of the top part, this part, is greater compared to this part. That is, our line is more nearest to this point, that is SK plus 1 YK. So in order to represent the line, we should select this particular point. Suppose if PK was positive, then it means D lower is higher. That means this distance is higher. Then in order to represent our line, we should select this SK plus 1, YK plus 1. Now, so we are using this technique to draw the given line. So first one is input the endpoints and store the left endpoints as x0, y0. That is, we will be having two endpoints, out of which this left endpoint should be stored as x0, y0. So the first thing, we have to calculate dx, dy. Dx is x2 minus x1, dy y2 minus y1, 2 dy, 2 into y2 minus 1, then 2 dy minus 2 dx. We have to calculate all those things. The first thing is p0, or we have a value pk. So initial value of pk is p0 because k is initially, it is denoted as 0. So first value of p0 is 2 dy minus 2 dx. Initialize k is equal to 0. That means first pk, p0. We are initializing this as p0, and to that p0 we are storing the value 2 dy minus dx. So we have p0. So I have already said this p0 or pk, this is dx into d lower minus d upper. If we are doing the mathematical part, we can find this pk is this one. Now, if pk is less than 0, pk is less than 0, here p0 is less than 0. Pk means it is d lower minus d upper. So it is less than 0 means d upper is greater. D upper is greater means our line is more nearest to this point. So we have to plot this point. So if pk is less than 0, then plot sk plus 1 yk, that is this point. And then we have to change the value of pk plus 1. We have to give a new value to pk plus 1, and that is equal to pk plus 2 dy. That is, next one we have our present value, it is p0. So now this one will be p0 plus 1, that is p1 is equal to p0 plus 2 dy. Or else, if this pk were greater than 0, that is d lower is higher, then we will select this point. So if else means pk greater than 0, then plot this point sk plus 1 yk plus 1, and then our new p1 will be pk plus 2 dy minus 2 dx. Then after that we will come out of this loop. Again we have a new pk value. So the present one is p1 value. So then we will compare whether p1 is greater than 0 or p1 is less than 0. Again we will go through this loop, and like that plotting will continue till we reaches the right end. So this is Bresenham algorithm. Thank you.